In this video, we will look at the idea of percent change in a couple contexts involving population. So let's look at this example. The table below shows the population of a city in terms of the number of years since the beginning of 2000. We'll assume that this population grows exponentially. So since the population grows exponentially, we expect to have a constant growth factor. In particular, we should have a constant 1-year growth factor. So if t increases from 0 to 1, a change of 1 year, then the population becomes some number of times as large. So it becomes 3120 divided by 3000 times as large. And 3120 divided by 3000 is 1.04. So from t equals 0 to t equals 1, a change of 1 year, the population becomes 1.04 times as large. Therefore, the 1-year growth factor for the population is 1.04. And we can expect that any time 1 year passes, the population becomes 1.04 times as large. Since we have a constant growth factor, we can also expect to have a constant percent change. So let's see what happens when t varies from 1 to 2, another change of 1 year. So as t varies from 1 to 2, the population increases from 3120 to 3243, an increase of 3243 minus 3120, which equals 123. So over this 1 year period, the population increased by 123 people. So 123. Now this change in population, we'll call this delta P for now. This change in population is 123 divided by 3120 times as large as the population at the beginning of that 1 year interval. And 123 divided by 3120 is equal to about 0.04. So over this interval of 1 year, the change in the population is about 0.04 times as large as the initial population, or the population at the beginning of that 1 year interval. If we think of this in terms of percentages, this change in population is 4%, which comes from 100 times 0.04. So 100 times 0.04 gives us 4. So our change in population is 4% of the population at the beginning of that 1 year interval. And therefore, we would say that the 1 year percent change in population is 4%. Now, suppose the city's population grows exponentially by 7% per year. Let's explore what this actually means. So let's let f of t, we'll let f be a function where f of t represents the population of the city t years after some starting point. So f of t represents population after t years. So the population 1 year later would be t plus 1 years after that starting point. And so f of t plus 1 represents the population 1 year later. So here we're thinking of like a 1 year change in time. So from here to here, that's like plus 1 year. So we're looking at a 1 year interval. So over this 1 year, the population grew by 7%. So in this case, f of t plus 1, we started with the initial population of f of t, and then we increased by 7% of our initial population, or the population at the beginning of that 1 year interval. So we started with our initial population, and then we changed by 7% of that initial population, and therefore this population 1 year later should be 107% of our population at the beginning of that interval. So our new population 1 year later is 107% of our population at the beginning of the interval, and 107% of our beginning population is 1.07 times as large as the population at the beginning of that interval. So f of t plus 1, our population 1 year after the start, is 1.07 times as large as the population at the beginning of that 1 year interval. And therefore, this 1.07 is our 1 year growth factor. So we have a 1 year growth factor of 1.07 because we have a 1 year percent change of 7%.